So hello everyone, I am Baban Gayan and I'll discuss about some example MCQs for week 12. So I'll start. You can write the answers in the comment box here in the meeting only. So let me start. So first question is that suppose you are designing an RL agent and this is for a racing game. So basically your objective is that you should reach as fast as possible, as soon as possible to the finish line, and you have multiple options, and which set of rewards should you choose, so that the agent, or say in the hair car, reaches the fastest to the finish line. So first option is that +5 for reaching the finish line, and -1 for going off road. So basically here we are penalizing if the car is going off road, and we are providing a good reward if it is able to finish. Then the second option is that +5 for reaching the finish line, and -0.1 for every second. So like until the end. So for every second we are detecting we are giving -0.1 reward. Okay. Third option is that same, basically that +5 for finish line, -0.1 for every second before we reach the finish line, and +1 if the agent or if the car is going off road. So this is the third option, and final option is that -5 for reaching the finish line, and positive 0.01 for every second that we take before reaching the finish line. So which one of the four options will be the most appropriate reward? Which appropriate set of rewards? You can think about it, and you can write it in the chat box. So please keep in mind that we need to reach faster, like maybe like if there are two options, like reaching the finish line in 2 minutes and reaching the finish line in 1 minute, we should choose the option with 1 minute, because this is, we're talking about racing game. Okay, so yeah. Okay, I got an option B. Also another option B. Okay, first option. Okay, yeah. Okay, so the thing here is that there are so at first basically we want to teach the agent to reach to the finish line. So the last option, -5 for reaching the finish line, that is not at all correct, because if you are giving negative reward when the agent is reaching the finish line, then like it will try to not go to finish line. It will it will try to and also you are giving positive reward when the agent is taking a longer time in the track. So, in the fourth option, what will happen is that the agent will take like wait forever. It will like just move around the field without any attempt to go to, without actually avoiding to go to the finish line. Okay, and then another option, +5 for reaching finish line and -1 for going off road. So, the first option. So, although this seems a good idea, that yeah, like you will give reward if it is finish line, and if it is going off track, then it is okay, negative reward. So, it is trying to stay on track. But the issue is that we are not giving anything related to speed or like how much time it is taking to go to the finish line. Okay, so it doesn't matter if it is taking 2 minutes, if it is taking 1 minute, it will give the exactly the same reward, right? So in that case, maybe yeah, the agent will eventually reach the finish line, but how much time it will take, there is no like we are not really optimizing that. So that is not really a efficient behavior for a racing game. Then there is another third option. If you see that +5 for finish reaching the finish line, -0.1 for every second that passes before the agent reaches the finish line. So here and +1 for the agent going off road. So let's take the first 2 points first. So +5 for reaching the finish line, and minus negative -0.1 for every second. So in these two rewards, in these two set of rewards, what is happening is that we are encouraging the agent to reach to the like finish line first, finish line, and we are deducting 0.1 for every second, so that if it is taking maybe 2 minutes, it will get much negative reward compared to if it is taking 1 minute. So it is like 60 into minus 0.1, so that is like -6, and if it is like taking 120 seconds, then it is like -12. So it will prefer 1 minute race over like 2 minute race. So that is first 2 points are fine, but +1 for agent going off road. So basically in this case we are giving positive reward if the car is going off like outside of the track. So that is not really a good behavior in the racetrack. So first of all, if you go off track, the speeds will reduce, and also there are some penalties. Like it is actually generally not allowed or encouraged. So, but in this case, we are actually giving +1 if the agent is going off road. So that is not really a good option, and so the only option which is making sense in this question is option B, that +5 to reach the finish line and -0.1, so that the agent is trying to finish go to the finish line faster in like shortest amount of time. So I hope it is clear to everyone. Yeah. So I'll go to the next question. Yeah, this is a very simple one. It is RL methods learned to experience, prediction, or analyzing the data.
Analyzing the data. Sorry, experience.
Yeah. Yeah. So basically, in RL, we basically what the agent does is that it interacts with the environment and then gets a feedback. So basically, at first the agent makes mistakes. Basically, randomly we take some action, then we get some reward. If it is good action, then we get good reward, like that. So over time, the agents learn that doing this action at this state is not a good idea, but doing this is a good idea. So from experience, it is learning what is good and what is bad. So that is why the correct option is experience. Okay, so which of the following is an practical example of RL? So, house price prediction, market basket analysis, text classification, and driverless cars.
Driverless cars.
Yeah. So again, I think like all of you are aware that there are already driverless cars, and actually RL is extensively used on those cases. So otherwise, like in case of like housing price prediction, you know that there are label data, and we can easily learn through the patterns in the label data. So basically that is not really a very efficient method for like efficient solution. Like RL is the efficient solution there. Same for the other options also. So the correct option is driverless cars. Okay, so we have a equation which is covered in the lecture, and basically this is a generalization error, and the question is that what does the D mean here? Option A is that underlying distribution that we are trying to estimate. Option B a sample of the underlying distribution. Option C is that a different distribution that we are trying to estimate, and that is like not the underlying distribution but a different one. And option D is that universe of distributions.
Option A, the underlying distribution we are trying to estimate.
Yeah, basically, yeah, option A is correct here because we are actually sampling some we are sampling from the distribution that we are trying to estimate here. So, and this is basically the like if it is like kind of like error. Okay, so we are sampling from the distribution and we are trying to estimate the error. So yeah, this is the correct option. Okay, so some more MCQs, then there are one or two numerical problems also. So here most of the classifiers minimize empirical risk, that you know. So there are multiple options here, and you have to find out uh, which one of them there is a like exception, which does not solely tries to minimize the empirical risk. First one is that perception training algorithm, second one artificial neural network, and third one is support vector machine. Fourth option is both A and B, and last option is none. All of them tries to minimize the empirical risk. Okay, so the correct option here is that option C, because you know in perception training algorithm what we do is that we try to minimize the loss function. Same for neural networks. There is some like loss function can be different, but or basically we try to minimize the loss. But in case of support vector machines, in addition to the loss function, we also try to maximize the margin, right? So not only the risk but also the margin we consider. So that is the correct option here, SVM. Okay. Okay, so this is a numerical question. You have P of AI equal to 2 to the power minus I, and you have to calculate the upper bound of P of union I to the, this equation, and using union bound. So you know the formula of union bound, that what can be the maximum value of this. So using that, can you found the like maximum possible value given P of AI equal to 2 to the power minus I. Yeah, I'll give you some time to solve. You can solve it on pen or paper or whatever.
So here we are asked to find the probability of A1 union A2 union A3 union A4 union A5.
Yeah.
And we know the probability of A1 is 1 by 2, probability of A2 is 1 by 4, probability of A3 is 1 by 8, probability of A4 is 1 by 16, and probability of A5 is 1 by 32.
Yeah.
Now, given those, how do you find the probability of A union this thing? So that is, I think, probability of A plus probability of A2 plus probability of A3 plus probability of A4 plus probability of A5 minus probability of A1 intersection A2 minus probability of A2 intersection A3. Is that the way to be done?
Yeah.
So how do you get probability of A1 intersection A2, for instance?
Okay. So here we have discussed that upper bound. Okay. So what can be the maximum? Under what situation it will be the maximum?
Upper bound will be always 1 for probability.
Upper bound of this. So like in the equation that you are saying, P of like a
Upper bound will come when they're all disjoint.
yeah.
AIs are disjoint.
Yeah. So when they are disjoint, what will be the value that you have to calculate?
Okay, when they're disjoint, then you have to multiply all the probabilities. Is that so?
No, no. So the equation that you are saying, like P of AI plus P of A2, that one only. But after that, you said there is intersection. But if we are trying
Oh,
to
okay.
calculate
Then
upper bound, then the intersection is 0.
0.
Yeah.
Okay, okay. So it's just the sum of all.
Yeah.
0.5 plus 0.25 plus 1 by 8 plus 1 by 16 plus 1 by
Yeah.
32. Okay.
So basically, this is the formula that we are trying to calculate. U union of I equal to 1 to 5 and AI. So with union bound formula, that should be less than equal to summation of I equal to 1 to 5 P of AI. So basically it will always be less than or equal to 5. When it will be equal to 5? When it is like disjoint. So yeah, everything is disjoint, then it will be equal to. Otherwise, if there are some intersection, then it will be actually lesser. Because in the right hand side there will be some intersection, minus intersection. So like that is why. So it will be like always lesser. I'm sorry, like yeah, when there are some intersection, then yeah, this will be lesser compared to this, because you have to also consider that the intersection point. So if you are trying to find the maximum, then this is the maximum that we need to find. Summation of I equal to 1 to 5 P of AI, and that means what? P of AI is to the power minus I. So that is what we have put here. So basically this is the just we are expanding to the power minus 1 to the power minus 2 minus 3 minus 4 minus 5, and that is basically just half 1 by 4 1 by 8 1 by 16 and 1 by 32. You just take the denominator 32, here you will get 16 8 4 2 1, and you sum all of them, you will get 31. So the upper bound of the this one is 31 by 32. So if you just divide this is coming out to be 0.96875, and which is 0.969. So this is in the third option, 0.969. So this is actually the correct option. So if you have any doubts in this, please feel free to ask. So let me go to the next question then. What is a policy in reinforcement learning? So first option is that it is a mapping from state to action. Second option is state to reward. Third option is that action to reward, and fourth option is action to next state. So these are the four options. So what like which of the option is like what we call policy? Option C and option E. Mapping from state to action and action to reward. Okay. Okay, I will show you a diagram. Yeah. So policy means like in RL, policy means that what the agent should do given the states. Okay. So basically, if you go through the diagram here, what is happening is that the agent is taking some action, and that is basically the policy here actually. So basically, given something, given some state and maybe other information, yeah, like given the state, what the agent should choose, like what should be the strategy of the agent. So that is we call policy. Okay. And then after choosing an option like an action between multiple possible actions, and then like after taking the action, the environment gives a reward and gives a new state. So basically what is happening, you can consider that maybe you are playing a game of chess, and you are just a second. Let's try to show you an example. So basically this is the state here. Okay. So I am playing as white, and initial state is like this king is at this position, this king is at this position. Okay. So this is the position. Then suppose I have multiple options now. Okay. So I can move this forward, I can move this forward, here, anything. Okay. So these are the all the possible actions. So
Nothing is shown. Excuse me. Nothing is being shown. Only the question.
okay,
What
yeah.
you are writing?
Okay, just a second. Yeah, is it visible now? So I'm just showing a chessboard.
Yes. Yes. Now.
Yeah, yeah. So basically, you are suppose you are starting to play a game of chess, and you have at first you have this position. Everything is in the default position. So this is your current state, and you have multiple options. You can move this forward. You can move this one forward, any pawn forward. You can move this knight forward here also, like many options. Okay. So, what does policy means is that you have this state, and given this state, what should be your strategy to like have the maximum reward in this environment. So, suppose I am playing a move, okay, and then computer will also place a move. So, this is a new state, okay. So, uh, after an action, the environment also like the bot is also playing a move, and our new state is this one, and because I haven't captured any pieces or anything, the reward is maybe 0, okay. Then suppose I am moving this here, and this is again after he has like after the bot has taken my piece pawn here. So, in that case, like maybe I am getting a -1 reward, that you have lost your piece. So, basically what is happening is that we are taking an action, and the environment is deciding the reward, and also the next step, that after the pawn is taking here. So, this is the new position, new step, right. So, these are not really in control, that these are actually provided by the environment. Uh, so, if you look at the options here, so action to next state, it is actually given by the environment. If you are taking an action and the reward, it is also given by the environment. And state to reward, if we are at some state and we are making a move, after that the environment is giving some reward. So, again this is in not really in direct control of the agent. So, only thing that is in direct control of the agent is that given the pieces at this position, I should play this move. So, this is a mapping from given this state, what action should I choose. So, that is why we call it policy. So, what should be the strategy of the player or the agent to get the maximum reward. So, basically the correct option here is state to action, because even though indirectly our objective is to get maximum reward, but the only thing that is in agent's control is taking the action. So, option A is the correct option, not option C. So, we have two statements here, and you have to answer like if both are correct, both are wrong, or if one is explaining another or not. So, first statement is that reinforcement learning is type of supervised learning, and option B is reinforcement learning does not have a labels. So,
Excuse me, sir. Please repeat the last question. What is the answer?
yeah, last question
Okay, the
answer,
first one.
yeah, first one, because policy means what should be the strategy of the agent, and only taking action is the in control of the agent.
Okay.
Yeah. So, we have two statements. RL is a type of unsupervised learning, and B, reinforcement learning does not have any labels. So, the options are both statements are true, and because uh, RL does not have any labels, it is unsupervised learning. This is the explanation. Then option B is that both are true, but statement B does not justify this one. Option C is that first one is true and second one is false. Fourth option is that this one is true, this one is false. This one is false, this one is true. And last option is that both are false. true, B false. Another one option is D and D. Okay. So 4 D options and 1 E.
So RL is neither supervised nor unsupervised learning. So statement A is definitely false.
Mm-hmm.
So does not have labels. Um,
So just consider the chess game. Does it have any labels?
yeah, like a chess game, each of the counters has label. No? This is pawn, this is queen, this is king, this is bishop, this is knight. So it has labels. No? Are they not called labels?
No, no. So this is so labels means suppose you are having, uh, let's say you have a sentence and you are saying that is it a positive? So output basically label in the sense here output. So suppose you
In
are
that case, both statements are false.
yeah okay. Oh sorry. So the option is D actually, not both. So actually, the statement B is reinforcement and does not have labels, right? So it is true, right? So if the option had been reinforcement learning have labels, then it would have been false. So labels here actually mean that expected output. So if you consider supervised learning, uh, maybe you are considering that sentiment of a sentence like I really like the movie. Okay, so that is the sentence and the sentiment is positive because like I liked it, so that is positive, right? So basically uh, in case of supervised, we have input and labels. Labels mean to train the model we have the expected output, that yeah if this is the input, that should be the output. So in case of clustering, we don't really have that. So basically if you are taking maybe a list of movies and you don't know any rating or any category or anything like that, uh, so basically what we do is that we don't have any labels. We want to basically put some similar movies in the same cluster. So that also do not have any labels. In case of chess game, uh, we have that we have the in the input we have the current state. Okay, we have the current positions. So this is for supervised and this is for we have the current position, but do we have what should be the expected move? We don't have that, right? Expected action, we don't have that. We are learning it. We are choosing some action. We are learning. We are learning that that move is good, that move is bad, and that is how we learn. We don't have any label that this move is the best one here. Like this one, this one is the expected move if we are at this position. So that is why like this statement B is true, that it does not have any labels, and statement 1 is false because RL is not really an unsupervised learning. Unsupervised learning, you can consider the clustering one, that is unsupervised learning. But in unsupervised learning, what we do is that we learn from the pattern in the data. So if some of the movies are in like similar, then we try to put them into the same category. So even though we don't have labels, we try to find patterns within the data and we try to group them. But in case of RL, we don't rely on the data, we just interact with the environment and learn from the experience. So this is not really an unsupervised learning. Okay. Okay, so this is the last MCQ, then I'll just show you some demo. So you have an RL agent and you want to teach it to play golf, and you have a program to simulate the same, and suppose initially you are giving plus 10 when golf ball is hitting to the hole, okay, and negative 1 if it is not hitting into the hole. So basically here also the objective is that to reach the to finish the game as soon as possible, right? So then you decided that to make it faster you will give additional plus 3 reward whenever the ball reaches within a certain range of the hole. So okay, let me okay. So suppose this is the environment here. So initially suppose your ball is at here and you have to move the ball here, and you can make multiple moves. So initially when you are reaching here we are giving 10, otherwise negative 1. But now you decided that if the ball is within this hole, every time the ball is within this hole, this area, this green area, you will get positive 3. And sorry, I'm not sharing the type actually. Yeah. Okay. So this is the golf say field, and your ball is currently at tee boxes levels at very far away, and you want to put the ball into the hole slash cup, that position, and initially you are giving 10 if the ball was reaching here, but now you decided that you will give so here green area surrounding the hole or cup. So you decided that if the ball is reaching that area, every time it is reaching that area you will give positive 3. So will that help at all? Will that be beneficial? So you have multiple options. First option is that yes, it will help to speed up the learning because we are also giving rewards when it is reaching near the goal. Then option B, that if the ball is getting within certain distance of a hole, then it is kind of like a sub goal. It is near to the goal, and maybe in next few minutes it should be able to reach there. So it should be rewarded. And option C, that no, it will not help, but it may actually harm in the learning process.
Yeah, this I think it's option C because this question requires knowledge of the game golf. I think because even if the ball is within 1 meter of the hole, it need not it need not imply that you are actually closer to winning. It depends on the type of stroke that you give.
Yeah. So, but yeah, you are right. But consider this, that if so, okay, yeah, even though it is not when it is not guaranteeing that it will reach the goal, but it is very near to the goal. So do you think you should encourage something that is, so suppose you are yeah, you should encourage something that is very near to the goal. Why that can be a bad idea here?
Because even if you are near to the goal, there is no guarantee that you will finally get the ball into the hole.
Yeah. That is right, but if you are near to the goal, it is easier, right? So suppose if you are at 10 meter away, then it is very hard to reach the hole. But if you are
Okay.
so no,
Right.
your answer is correct, but your like explanation is wrong actually.
Oh.
Yeah.
I don't know.
Yeah. So let me see some other options. Okay, no other option. Okay, I'll just draw a diagram. Okay, so suppose you have the hole here. Okay, this is like a flag, and basically what they are suggesting is that we have a certain area. If the ball is coming under this area, it will get rewarded. Okay, rewarded something, and if it is here, it is plus 10, and here it is plus 3, and your starting point is from maybe here. Okay, so here the reward is -1, like for every move. Okay, so what will happen is that, yeah, it initially it seems that good idea, that even though if it is not able to reach here, even though it is not able to reach here, even if it is reaching somewhere, then it is kind of a signal that, yeah, even though you are close to the goal, so good job, that kind of thing. But the issue is that in the question we have mentioned that every time it is coming to here, to this place, will give positive reward. So what will happen is that the agent is suppose coming here. Okay, the ball is coming here, then ball is maybe coming here, second move, third move, it is getting positive 3 reward. Okay, now it is initially it was like -1, then -1, then +3. Okay, then
So within that circle itself, it can keep on going +3, +3, +3, and even
exactly,
reach 10, but not get into the hole. Yeah.
exactly. So that is the problem. So what will happen is that in this case, there is +10 reward here if the ball is reaching hole, but the agent will decide that, yeah, +10 reward is there, but if we go there, it will stop. So once you have won, there is no further reward. So after that, you have two options, +10, or other options are 3, then again play, maybe come here again, then again here. So you just, if you just move around the circle, if you just move around the area, it will continue getting 3, 3, 3, 3, and so on. Okay, so after reaching here, the agent will decide that it is more beneficial to just roam around the area rather than going to the hole, rather than finishing the game. So that will actually, it will just go on infinite loop to just roam around the red area, and it will not make any effort to actually win the game. So that is why it will here in this case it is not beneficial. So this is actually called reward hacking. So this is a concept that if you are if your rewards are not well defined, then agent will go out of their way to get the maximum reward, and it will not work as you expected. So like, even though your plan was to encourage the model to get a kind of like feedback that they are doing good, but in this case it is kind of trying to take advantage of that situation. Okay, so that is why like it will not work here. So I hope it is clear to everyone. So these are the questions that we are supposed to discuss today, and there are some coding solution exercise that I wanted to show. So this is not really related to the syllabus. This will not come in the assignments or in the exams, but I just wanted to give some interesting solid examples with RM. So this, yeah. So this is the basically what we are trying to do is that initially, so we have the graph here, okay, and initially we are starting from 0, and our goal is to reach a node 7, and our goal also is to go as fast as possible, not 0 to 1 to 5 to 4, then again coming back to 5. That will not make any sense. Okay. So initially we are just using some standard libraries and edges list. Edges list, we have a node from 0 to 1, 1 to 5, and 5 to 6, 5 to 4, 1 to 2, 2 to 3, and 2 to 7. So these are the list of edges. So they are basically bidirectional. Okay. So if there are node from 0 to 1, there is 1 to 0 also. So then we are using just a diagram. So network X is actually a library to draw diagrams, nothing fancy here. So you can just see the diagram here. So 0, and the optimal part is 0 to 1 to 2 to 7. Okay. So basically, how many nodes do we have? Total 8 nodes we have. So we will create a 8 into 8 matrix. Okay, to find to, so basically we want to create a matrix that from this node where to go, so that we can get maximum reward. From this node where can we go to get the maximum reward. Okay. So there are 8 nodes and we can transition into 8 other nodes. So 8 into 8 matrix will create. So that is what we are doing, np.matrix, np.1. So we are basically just initializing the matrix with 1, and then we are multiplying the whole matrix with -1. Okay. So R here, R is the reward matrix. Okay. So R is the reward matrix, and we are initializing it with 1, everything with -1. Okay. So initially we are saying that every move you will get -1 reward. Okay. But there are some other cases. If we are reaching the goal 7, then what we'll do? We'll give the 100 reward. Okay. And if we are yeah, and also if okay, so let me just show you. So basically yeah, so at first yeah, you can see at the goal node. Okay. This is 7th node 7 to 7. So 7 to 7 we can just self loop. Okay, it is not shown here, but consider that it has a self loop. Okay. So all the nodes actually. Okay. So in this case, if you are already at 7, the reward is 100. If we are at 2, then we can reach node 7 in just one step. So the reward is 100. And in other states like maybe 2, so 0 to 2, here this is 0th index and this is 0 1, 1th index. Okay, 0 to 1. So 0 to 1, this one, and 1 to 2, again 0. So basically what we are showing is that if there are some legal moves like 0 to 1 we can go, we are giving 0, 5 5 to 4 to 5 we can come, we are giving 0. But if we are choosing 6 to 1, there are no edges, right? We cannot go 6 to 1. So that is impossible move. So if the agent is choosing some impossible action, we are asking that no, this is not really a valid action, we cannot just go from 6 to 1. So you are giving a negative reward. Okay. So this is the like updated matrix. So yeah, I'll share the collab link. Okay, so I have not really uploaded it in the, so actually you can just refer to the this link. I have taken it from this link. Okay. So anyway, like I'll also share the collab notebook after the session is over within the folder. Anyway, so this is the like reward matrix after considering the rewards if we have reached the goal, if there is some invalid move, and if there is a valid move. Okay. So then our next thing is that we are choosing gamma. Gamma is what? This is a discount factor. So basically what we are saying is that basically we want that suppose you are at this point and you are getting if you are getting 50 reward here and you are getting 50 reward here but 0 here. Okay, so what is more beneficial, to go here or to go here? So in this case you can see if you go here, there are additional move, one move here, another move here. So just it might be more beneficial to come here because we are getting it the 50 reward in just in one move with less energy, right? So to like to encourage that behavior, we are setting gamma. Gamma is the learning. Gamma is the like discount factor. We are saying that as we are coming here, from 1 to 2, we are getting 50 dots, which is fine. But since we are, if we go to the 4, we are getting after one move. That means we will multiply it with 0.8. Okay, so 0.8 into 50 equal to 40. So we are considering that if we go to the 4, the reward is like 40, but if we go to the 2, the reward is 50. So kind of like even though in the both cases we are getting 50 reward, but we are with discount we are considering 2 as 50 and 4 as 40 because 4 is far away and we have to make much larger effort to go there. Okay. So then basically there are some functions that if we are at current state means at some node, what are the options that we can grow from here. So it will just return those. Okay, so it will ignore the negative one, which are really not really good move. Then out of available options it will choose an option. So sample next option here is, it is meaning that given the available option we will just choose one action randomly and will return the value. And then we have this update, we have update function, current state we are giving the action, and we have the gamma is the discount factor. Okay, so what we are basically trying to do is that we are trying to generate a Q function, and where basically what we'll do is that given a state and an action, we'll choose that under which action. Suppose we are at here, we are at point 1, and then so state is the point 1 and actions are go to 5, go to 2, go to 0, right? And Q function is that given state 1, if we take action 2, what will be the expected reward here, and what will be the expected reward, discounted reward of here, discounted reward of here, this all things. Okay, so not only the immediate reward but also discount of the what we are expecting if we are going here, and what after reaching here what is next. If we are going here, what is next, what is the expected reward there we are expecting to get, right. So this is we call Q function. So basically what we are doing is that uh, given multiple like given a state and multiple option, like multiple actions, possible actions, we want to find the maximum value, so that like we can choose. So suppose we are at here, we are at point 2 and the goal is 7. So what is the worst decision from point 2 to go to 7, not point 3? So if we choose the maximum, if we choose the optimal action, like what is the expected outcome? So this is the max value that we are considering. So basically this is a Q function here. Okay. So given current state and action, maybe from current state 1 and action is 5, go to 5, what is the reward will receive when reach that 5 node, and then gamma is the discount factor, and maximum value, which is the like what is the expected value that will get when we reach the node 5. Okay, and the discount multiplied. Okay, so this is the what we are doing here. So initially we are starting at initially we are just nothing is updated, q everything is nothing. So initially it is 0. So then what we are doing is that we'll running it for 700 steps, and then we are choosing any random state, and we are choosing some available action that given this state where can we go from this state, and then we are choosing some action, and given this action we are updating the Q function. Okay, that if this is the state and this is the action, what should be the what should be the expected, what should be the immediate reward, and what should be the future reward. Okay, so total, so that is the just Q table, and we are basically just updating that. So initially and we are every time we are just appending this thing, the Q value to the to a list. Okay, so and here is another condition. So here in this case we are not always starting from 0, we are just choosing like this, that yeah, maybe let's start from here, what should be the best move, maybe start from here, what should be the best move, like that. But then so by doing this we have a value that if from 2 the optimal is maybe 7, from 1 the optimal is maybe 2, from 4 the optimal is maybe 5, like that. Okay, so that we got there. Then during testing what we are doing is that we are giving 0, that please start from 0, and until you are reaching 7 select that wherever the Q value is maximum. Okay, so if you are at 0, choose that given we have multiple options, and from here so choose the action that that is having the highest Q value and take that action. Then when you reach the next node, again you choose the next again for maybe you are starting from maybe 6, then you choose that there are only option 1 here, so maybe 5. Then after reaching 5 you have 2 options, one is going to 4, one is going to 6, and another one is going to 1. So see the Q value of state and option 4, option 6 and option 1, see which one is the highest, and if you train the network properly you will see that 1 is the highest. So go here, then again take the Q value of state 1 with respect to option 5, option 0 and option 2, and then you will see that Q value is highest here, like this. You continue until you reach the current state equal to 7. So until you reach 7, just continue this step. So if I run this, what will happen is that it is just training. Initially everything is 0, okay, then at some point it is reaching the like goal node, then yeah, then like it is also considering the discounted reward, so it is getting like kind of updated. Okay, so initially everything was 0, okay, and after some point like this is the final matrix. So here it is like 0 to 0, like node 0 to 0, and the expected value is 0, 0 to 1 63. So if you go through the diagram here, 0 to 1, this is valid move, and we are saying that if you go to here, so maybe let's just start from like node 0, okay. So this is the matrix for node 0, and we have only one positive value 63. So 0 to 1 will go 0 to 1, okay, because this is the highest. So here here 0 to 1 we have came here 0 to 1. Now from 1 to where can we go? From 1 1 to 0 we can go, 1 to 5 we can go, 1 to 2 we can go, right. So this is the list for 1, okay, like 1 in 0th index, 1 index, like that. 1 to 0 51 reward, 1 to 3 is 2 79 reward, and 1 to 5 51 reward. So which one is the highest? 79, right. So we will go to 2 here. Again we have how many options? We have 3, we have 7, and we have 1, okay. So let's go to again 2, and where is the highest? It is highest in the last one, the 7. So if you go 0 to 7, we will get the highest value. So we are taking this part, sorry, 2 to 7 we will get the highest value. So here we have 3 options, but we are choosing this one. So this is how we end the goal, and when you are seeing that yeah, we are reaching 7, then yeah, we are terminating that, yeah, we are good, we have reached the goal, okay. So if you consider that initially we were taking just some random actions, okay, so our like rewards are really low, and over time, so we have trained for 700 steps, right, and yeah, 700 steps, and basically we are just multiplying everything with 100. So if you just yeah, so basically if you consider the like expected like the rewards, okay, so we are appending the scores here, okay. So if you consider that initially it was very poor, but over time as the key values are getting updated, we are able to reach like we are able to get very good scores, and if at this stage we'll be able to choose very optimal actions to reach the nodes at like very quickly. So from 0 to 7, or from whichever node, maybe let's consider another example. Maybe let's say from 6, when we start from 6, we should be able to reach, okay. Yeah. So maybe initial state is 6, then there will be multiple steps, 6 5 1 2 7. So 6 5 1 2 7, right. So this is how hurdle works. So this is called queue learning method. This is not really part of your examination or assignments, but just some like hands-on tutorial how to do it. So anyway, if you have any question, you can ask.
Sir, I have some question.
Yeah.
What kind of the question they are asking? Can we expect direct question from assignment? Some question, not all, at least 2 to 3 per assignment.
So you will get similar kinds, but direct questions I'm not really sure. But you will get very similar kind of exam, I guess. Yeah. Maybe
Okay,
like
sir.
in case of numerical, maybe some values will be different. This kind of thing might be there.
Okay, I have some doubt from the previous assignment also. So can I discuss right now?
Okay, so assignment actually, so I don't think they have released any uh, solution, right? Like
The
official
solution is already released. Up to 10, I think they have released.
answer key.
So actually, it's a Gaussian mixture model. I have doubt, not able to understand clearly. And then some a D separation rule. I have just found three D separation rule. Then I know this, but some problem in that. And the same way, some logistic regression. I find some problem. So that's why I want to discuss some questions,
Okay.
if you allow me.
Okay, so yeah, I'm not really prepared, but yeah, I can try. So yeah.
Sir, first thing in Gaussian mixture model, sir, can either you can provide me some direct link so that I can go through any example because I'm not able to understand it properly.
So I
And
think
from the lecture is not able to. I have watched so many videos from other
yeah,
YouTube also,
I
but
think I went through some diagrams actually. Sorry, some blogs which were good.
so I searched from Medium also, from data center, data science also, but could not find anywhere. That's so that one example through which I can understand clearly.
Okay. So you can actually refer to here actually. So
Sir, so many blogs are there, but nobody is able to provide the example clearly what is happening. But they are just E and M methods like that. In the E,
so
what is happening, how we are estimating, how we are taking the Gaussian, and then we are finding the likelihood. After that, like once you find the likelihood, then we can estimate the parameters. In M methods, how they are updating the parameters.
okay, so I think yeah, I can share a video.
And then what is exact the equation of the responsibility and also the from assignment also I'm not able to understand clearly how we can find the responsibility posterior probability. I think that is
Just I'll share you an yeah, rhythmic math. So you can follow it here. Okay, I'll just share you the link.
okay.
Yeah, this is actually a very good explanation. I have watched this. So yeah, you can get some idea here.
Which one, sir? I think it is not open.
Uh,
It's need
YouTube.
access. I think.
Uh-huh.
Just wait.
Yeah, I have just sent it in the chat.
So this is Q learning. I'm
No,
asking
no, no,
the Gaussian mixture
no, no.
model.
Just the YouTube one. I have sent in the chat box. Check in the meeting.
Yes, I have copied from chat box. This is Aman kuch Amanate GUI, I think.
This is rhythmic math. It should be. Let me just check it again.
And this second is Jamboard. It is asking the
No, not the
permission.
Jamboard one. So I'll
The
just
second, okay,
this one.
you,
Okay, just a second. This one. Okay, rhythmic math. So is it visible on the screen?
okay, yes, yes, sir.
So yeah, this is the and logistic regression, I guess. Yeah, a logistic regression. I'll also share. Uh, there is something called Josh Tamer.
So I think that is again a theoretical concept. It is just
No, no.
I need one proper examples.
Yeah, yeah. Josh Tamer is giving examples only. So StatQuest. Okay. So they have a series of lectures. So with intuition and everything, you will find. Okay. And I think I have some slides. So let me just wait a second. Just wait a minute. Logistic regression was in which week? Can you? Okay, let me just check.
Sir, in logistic regression also we are finding the I think cross entropy, right? Once we find the cross entropy, the we are passing to the sigmoid function 1/1 plus e key minus x. So one thing is we can estimate the parameters directly using linear regression and then we can put this in.
Hmm.
The another thing is we can also find the log likelihood. Now, how I can approach that using the log likelihood? For example, I have the new data point and I can find I want to classify it. Now, how should I approach this? I'm just asking the working example.
So I'm not really getting your question. So can
Sir,
you?
the logistic regression is there, right?
Mm-hmm.
Some data set is given,
Mm-hmm.
and you are asking one point. Now, to classify this whether this is positive or negative center,
Mm-hmm.
right?
Mm-hmm.
And use the logistic regression. Though, what the steps should I follow?
Okay. So first would be fitting the data. Okay. To the logistic regression model. So let me. Yeah. So basically, in logistic regression, you have kind of let's say. So basically, you have two parameters, okay, beta 0 and beta 1, and with training, I will get those values. Okay, like beta 0, beta 1, and
So, how we can get this beta zero and beta one?
okay, so there is a formula log p divided by 1 minus p equal to beta 0 plus beta 1x,
Yes, sir.
where
Yes, sir.
x is the input. So you have to kind of let's say find the beta 0 and beta 1 from there.
I think we don't require to find beta zero, beta one. We need to find log p upon one minus p, right?
Mm-hmm.
That is the log likelihood.
Mm-hmm.
And we just plug in to the sigmoid function 1 upon 1 plus e key power, whatever we are getting from you.
Mm-hmm.
That is the okay, or it may be I need to correct somewhere.
Yeah, that is one way of doing that. You can do that. So basically, in logistic, you can consider as linear only, but in linear you have you don't have any range, but in case of logistic you have like a range between 0 to 1.
And instead of finding this log line, can I find the simple using? I first use the from the given data set. I simply find AB parameters, and after that I just put these parameter into the logis sigmoid function. That's all. Will it work or not?
No, it will not work.
With the same thing, no problem. Either you can estimate using the log likelihood, or you can directly from the because the data set is same now. And they are saying that logistic regression is nothing but the sigmoid plus linear regression. So if you are estimating the parameter using simple linear regression and then put into the sigmoid function, so I think it should be work
But
because
during training, okay, so basically you have multiple parameters, like beta 0 and beta 1, okay, and because of the sigmoid, uh, presence or absence of sigmoid is actually affecting the beta 0 and beta 1. So so if you remove the sigmoid, then beta 0 beta 1 might be different even on the same data set if you are giving a model with sigmoid 1.
No,
So
sir. I think first we need to find the log likelihood. Na? So we are if we are finding the log likelihood, we are not using any sigmoid. That we are simply finding p upon p 1 minus p log. So once you find this, then you can put into the sigmoid. That is I am asking. We are estimating beta 0 and beta 1 using simple linear regression, and then we can use the sigmoid. And then when we can take any threshold agar 0.5 above, then we can take class 1. Below, I can say it is 0. So because I have not found any example related to this, I have so many examples from linear regression, but nobody is talking about this logistic regression example. In the same way, no example I have found from the Gaussian mixture model.
so yeah, I'm sharing a link here. Like this is actually a playlist, but this is actually explained very intuitively. Yeah, I have already shared, I guess. Yeah. So you can follow this.
Okay, sir.
Yeah,
Sendex, I think, or the state quest. Okay.
yeah.
I have checked this, sir. I think they are not providing much. This simply they are saying log likelihood you can find, and then you can put this plugin. This.
Then I'm not really sure like how to explain this. Uh, Let me.
Sir, they are asking very tough question in assignment, but when we are discussing here, this is very simple question. But in assignment, the level of the question is are very tough. I think. I don't know what happened in exam.
Yeah.
Totally, we are scared of these exams. Even we are not able to solve all the assignment question. Everything is provided here. We can use the chat gpt, we can use the uh, google search, everything we have video, but still we are not able to get 10 out of the 10, maximum hardly 8 or 9.
Yeah.
At least one question always be wrong, and in that cases if we are sitting in the exam, I don't know whether we are able to pass or not. And in lecture everything is not provided. They are the assignment levels very deeper, but in the lectures that is not deep.
So I really
i
like, yeah.
I
So
think, sir, you are also agree with it.
I can't really like comment on that actually. So like my task is to like just provide and discuss some previous year problems, previous year assignment problems. So yeah, you can check this. I haven't really checked this, but I think this can be relevant. Maybe you can check this. Yeah.
Yes, sir, this might be helpful. Yes, this is the good one, data might.
Yeah.
Thank you, sir. This may be
Yeah, yeah.
I get some help from this.
Another thing, you can also, okay, I'll just share you another link, logistic regression. So even though like this is like a whole chapter, okay, around 25 pages, but you don't need to really read all of that. Okay,
Yes, sir.
just focus on the relevant parts. Okay, so yeah,
Yes, sir. Please provide me one more example related to Gaussian mixture model, sir. That's to understand the algorithm properly. That we need at least one practical example. Code is provided there, but in still code we are not able to capture the things what is happening.
yeah,
So if you are able to calculate manually everything, then you can understand better.
yeah,
That is the my approach. So I'm thinking like that. So if I'm not able to calculate manually, then it means I'm not able to understand algorithm properly.
yeah.
So if you provide this any link that can step by step solution of any examples,
Okay, so
Gaussian mixture model.
okay, I'm searching a bit, but okay.
Yes, this I have. Second, already have, sir.
Okay,
Yes, I got this.
okay.
Second is already logistic regression. Second one I already have. I have downloaded somewhere else. I think this is CMU or something else.
Yeah.
I don't know exactly. But now the Gaussian mixture model, if you have any link.
Okay, I'm looking into it.
Sir, any trick that you can share so that we can pass in exam? You can
Uh,
provide any tips.
I
At
would,
least we study all the assignment 2 to 3 times. No doubt in that.
but
Apart from that, you can say
also look at the practice assignments.
okay.
Yeah, and
And then video lecture, sir, we don't have much time because we are working and not. I have tried to watch all the videos, but not right now. The revision is not possible. That's why I'm asking if you can share any.
so yeah, yeah. Like right now, like you are focusing on revision. So yeah, I think just look at the assignments, of course, but then also uh, all the problem solving sessions, all the slides that we have shared, generally they are assignment solution from the previous year. So also look at those slides, whatever we are discussing. So
Sir, where I can find these previous slides?
uh, okay, let me just share it with you.
Sir, if we are not able to pass this exam, then definitely 1 year back will be there. That is the problem. Minimum 60% we need from this exam. And if failed, then definitely 1 year will be back. So request you, so please share some tips so that at least
So
we can pass.
actually, I have never given this exam. Okay, so I don't really know how to write this. But in NPTEL, other subjects, I have seen that generally.
Sir, other subjects some are very simple, but if particularly in case of machine learning, that's I think I expected much tougher paper as compared to others. Uh, I have also enrolled computer vision. That is not much hard as compared to this. The assignment level is also okay. If we are able to consume, then we can get 100 out of 100. But here, totally everything we have, but still not able to get out 100 out of 100. Maximum 8 I got right now.
Yeah.
I was, I'm not hiding anything. I have the chat GPT, I have the Chromes, everything I have. I can search everything there. But still, two question at least, 1 to 2 question you will find the wrong.
So, do one thing. I have shared a spreadsheet, and in this spreadsheet you have the TNMs and yeah. So you have
Yes, sir. This is okay.
drive link.
Yes.
So in the drive link we have the PowerPoints. Okay.
Okay,
So
sir.
go there and solve the questions, and uh, try to understand why actually this one is the correct option, because in the exams, even though obviously exactly similar thing will not come, it might be maybe numerical values will be changed a little bit, maybe it will be um, somewhat uh, written differently like that. So make sure that solution to the questions you have in your mind, your conceptually it should be clear that because of this reason this is correct and this is not correct. So
Yes, sir. This is happening only when if you are able to understand the algorithm correctly, then you can change. If even there is any change, you can solve it. That's why some of the topics like Bayesian networks, Gaussian mixture model, and some confusion in logistic regression, and then linear discriminant analysis. So these are the some topics. Then
are you familiar with Python?
I know, sir.
Okay, so actually Gaussian mixture model is really complicated algorithm. So that is the
Yes.
reason I think that there aren't any readily available example. Okay, so maybe you can look through the sklearn module. Just the like again, Gaussian mixture model is also like really complicated in the code also. But to get the overall process, you can refer to the like documentation, like sorry, code of the GUM in the like sklearn, that you can do.
Okay, sir.
But yeah, like very important thing is that yeah, also like maybe focus on I don't know like if numerical questions will be more, but uh, just like prepare for those also.
No, sir, at least I just know how the algorithm is working. That's all. How we can find the responsibility, how we are calculating, what is the step in what are the E step, and then what are the M step, how we are updating the parameter. At least we know. Then the rest of the calculation we can do from the system as well,
Yeah,
or we can take the help of calculator. But if still we are not able to understand the algorithm, then even you can change or you can put the same thing. Uh, uh, how you can solve it?
yeah,
That's yeah.
yeah, I understand that.
Sir, in exam, will we get questions like that in week 11 we solved, right? Gaussian mixture model, programming kind of questions in Colab we tried.
Okay, so there will be no coding question.
Okay, so those kind of questions won't be there, right?
No. So like only MCQs and multiple select questions, those will be there. Well, okay then. So prepare.
Okay, sir. Thank you.
So yeah, sample paper is not really available. Okay. So yeah, thank you
Okay,
everyone.
sir.
Thank you, sir.
Thank you.
Hello, sir.
Hello.
Hello.
Hello. Hello.
Yes, sir. Can you share that Q Learning notebook link?
Uh, okay. Just a second. Okay. So I don't really know like how what will be difficulty.
Thank you, sir.
Yeah. It is expected that it will be similar pattern, but I really can't really comment on the exam because I don't really have any idea.
Sir, at least we are expecting 2 to 3 questions per assignment directly. That's why we even otherwise it will be very difficult to pass.
Yeah.
At least 2 to 3 that we can revise the assignment. We have tried our best. We have attended almost every sessions, watched the video, but still not convinced. I'm truly speaking, sir. I don't know about the others, but
So
the
I really understand your like concern actually, but I really can't comment on this. I have no like control over that.
okay, sir.
So
Now we can leave. I think, sir.
yeah, yeah,
It is over. Okay, sir.
yeah. So Thank you, everyone.
Thank you.